Okay, today we're going to talk about linear inequalities. It's very similar to linear functions, but you get to color a little bit. You get to shade. So if you have a really good grasp on linear functions, this will be pretty easy concept, and we'll move pretty quickly through this. So linear inequalities. An inequality is a less than or greater than symbol, or less than equal to symbol, or greater than or equal to symbol. So step number one, you're going to be able to write the equation. So on this one, you're going to be able to find the slope and the y-intercept. So 1, 2, pin's not working. So 1, 2, 3. So you've got your slope is 2 over 3. So rise over run, 2 over 3. And then your y-intercept, right here where it intersects the y-axis, is at -2. So from this, you're able to write your linear function, which is y equals 2/3 x plus a -2, or you can just say -2 or -2. Okay, on this one, same thing, but you've got your rise is 1, 2, and then your run is 1. So 2 over 1. And then you can decide whether it's a positive or negative correlation. That means a positive or negative slope. So that is a negative slope. And then your y-intercept is right here, which is at 3. Okay, so now you can write it into slope-intercept form, which is y equals -2x plus 3. Okay, so once you've written it into slope-intercept form, then you're going to decide whether it's going to be a dashed or solid line. So this should be slope-intercept form. Determine the line. It's going to be dashed or solid. Okay, for it to be a dashed line, it needs to be less than or greater than. So that means that it can't be equal to things on that line, on that linear function. It's not going to be equal to. So this is going to be dashed. Okay. In order for it to be equal to, in order for it to be solid, it has to be equal to. It has to have this equal to sign up below the greater than or less than sign. So a solid line means the solution includes the boundary line. So whenever you're graphing your linear function and it is a solid line, it means it's equal to everything on that line. But if you have a dashed line, it means it's not equal to things on that line. It's either greater than or less than. Okay, so now we've written it in slope-intercept form. We've decided if it's dashed or solid line. The next step is to determine what is the shading. Are we going to shade above or below? So this is the part where you get to color a little bit. So this is where you shade. Okay. When you're trying to decide whether it's going to be above or below your shading, so you're going to shade above the line for greater than. So in this case, this linear function is y is greater than 2/3 x minus 2. That is this function right here. It's the same one, but it is in a linear function. So this is in slope-intercept form with an equation sign, and this is with an inequality. You kind of see the difference in how the graphs look. On this one, it says to shade below the line for less than. So this one will be y is less than negative 2x plus 3. Okay, that's when you decide whether you get to shade, and then you get to really shade them. So whenever you're really doing this, you will get to shade and color, and you can finally say that you got to color in algebra class. So I really enjoy this. I think we're actually going to stop right there because we're not to systems of linear inequalities yet. We will get to that soon, but we'll leave that for a later date. So right now I just need you to know, first you solve in slope-intercept form. So if it's in standard form, you have to change it to slope-intercept form. And then you graph it normally. You just graph it just like this. And then you decide whether it's going to be dashed or solid line. So if you go ahead and just do it in pencil first, then you can erase your shading, whether it's a dashed or solid line. And then depending on the sign, the inequality, it's going to be above or below for shading. Okay, I hope this helps. Thanks.